Later, we're going to be focused on pre-processing data, getting it into tensors, so turning data from raw form, images, whatever, into a numerical encoding, which is a tensor. Then we're going to look at building and using pre-trained deep learning models, specifically neural networks. We're going to fit our model to the data, so we're going to show our model or write code for our model to learn patterns in the data that we've pre-processed. We're going to see how we can make predictions with a model, because that's what deep learning and machine learning is all about, right? Using patterns from the past to predict the future. And then we're going to evaluate our model's predictions. We're going to learn how to save and load our models. For example, if you wanted to export your model from where we're working to an application or something like that. And then finally, we're going to see how we can use a trained model to make predictions on our own data, on custom data, which is very fun. And how? Well, you can see that the scientist has faded out a little bit, but that's not really that true. We're going to do it like cooks, not chemists. So chemists are quite precise. Everything has to be exactly how it is. But cooks are more like, oh, you know what? Add a little bit of salt, add a little bit of butter. Does it taste good? Okay, well, then we're on. But machine learning is a little bit of both. It's a little bit of science, a little bit of art. So that's how we're going to do it. But I like the idea of this being a machine learning cooking show. So welcome to Cooking with Machine Learning, Cooking with PyTorch with Daniel. And finally, we've got a workflow here, which, ta-da! We have a PyTorch workflow, which is one of many. We're going to kind of use this throughout the entire course. Is step 1, we're going to get our data ready. Step 2, we're going to build or pick a pre-trained model to suit whatever problem we're working on. Step 2.1, pick a loss function and optimizer. Don't worry about what they are. We're going to cover them soon. Step 2.2, build a training loop. Now, this is kind of all part of the parcel of step 2, hence why we've got 2.1 and 2.2. You'll see what that means later on. Number 3, we're going to fit the model to the data and make a prediction. So say we're working on image classification for ramen or spaghetti. How do we build a neural network or put our images through that neural network to get some sort of idea of what's in an image? We'll see how to do that. We'll evaluate our model to see if it's predicting BS or it's actually going all right. And number 5, we're going to improve through experimentation. That's another big thing that you'll notice throughout machine learning, throughout this course, is that it's very experimental, part art, part science. Number 6, save and reload your trained model. Again, I put these with numerical order, but they can kind of be mix and match depending on where you are in the journey. But numerical order is just easy to understand for now. Now, we've got one more video, maybe another one, before we get into code. But in the next video, I'm going to cover some very, very important points on how you should approach this course. I'll see you there. How to approach this course. This is how I would recommend approaching this course. So I'm a machine learning engineer day to day, and learning machine learning to coding machine learning are kind of two different things. I remember when I first learned, it was kind of, you learned a lot of theory rather than writing code. So not to take away from the theory being important, this course is going to be focusing on writing machine learning, specifically PyTorch code. So the number one step to approaching this course is to code along. Now, because this course is focused on purely writing code, I will be linking extracurricular resources for you to learn more about what's going on behind the scenes of the code. My idea of teaching is that if we can code together, write some code, see how it's working, that's going to spark your curiosity to figure out what's going on behind the scenes. So motto number 1 is, if in doubt, run the code. Write it, run the code, see what happens. Number 2, I love that. Explore and experiment. Again, approach this with the idea, the mind of a scientist and a chef, or science and art. Experiment, experiment, experiment. Try things with rigor like a scientist would, and then just try things for the fun of it like a chef would. Number 3, visualize what you don't understand. I can't emphasize this one enough. We have 3 mottos so far. If in doubt, run the code. You're going to hear me say this a lot. Experiment, experiment, experiment. And number 3, visualize, visualize, visualize. Why is this? Well, because we've spoken about machine learning and deep learning deals with a lot of data, a lot of numbers. And so I find it that if I visualize some numbers in whatever form, that isn't just numbers all over a page, I tend to understand it better. And there are some great extra resources that I'm going to link that also turn what we're doing, so writing code, into fantastic visualizations. Number 4, ask questions, including the dumb questions. Really, there's no such thing as a dumb question. Everyone is just on a different part of their learning journey. And in fact, if you do have a quote-unquote dumb question, it turns out that a lot of people probably have that one as well. So be sure to ask questions. I'm going to link a resource in a minute of where you can ask those questions. But please, please, please ask questions not only to the community, but to Google, to the internet, to wherever you can, or just yourself. Ask questions of the code and write code to figure out the answer to those questions. Number 5, do the exercises. There are some great exercises that I've created for each of the modules. If we go, have we got the book version of the course up here? We do. Within all of these chapters here, down the bottom is going to be exercises and extracurriculum. So we've got some exercises there. I'm not going to jump into them, but I would highly recommend, don't just follow along with the course and code after I code. Please, please, please give the exercises a go, because that's going to stretch your knowledge. We're going to have a lot of practice writing code together, doing all of this stuff here, but then the exercises are going to give you a chance to practice what you've learned. And then, of course, extracurriculum, well, hey, if you want to learn more, there's plenty of opportunities to do so there. And then finally, number 6, share your work. I can't emphasize enough how much writing about learning deep learning or sharing my work through GitHub or different code resources or with the community has helped with my learning. So if you learn something cool about PyTorch, I'd love to see it. Link it to me somehow in the Discord chat or on GitHub or whatever. There'll be links of where you can find me. I'd love to see it. Please do share your work. It's a great way to not only learn something, because when you share it, when you write about it, well, it's like, how would someone else understand it? But it's also a great way to help others learn too. And so we said how to approach this course. Now let's go how not to approach this course. I would love for you to avoid overthinking the process. So this is your brain on fire. So avoid having your brain on fire. That's not a good place to be. We are working with PyTorch, so it's going to be quite hot, just playing on words with the name torch. But avoid your brain catching on fire and avoid saying, I can't learn, no. I've said this to myself lots of times and then I've practiced it and it turns out I can actually learn those things. So let's just draw a red line on there. Oh, a thicker red line. Yeah, there we go. Nice and thick red line. We'll get that out there. This doesn't really make sense now that this says avoid and crossed out. But don't say I can't learn and prevent your brain from catching on fire. Finally, we've got one more video that I'm going to cover before this one gets too long of the resources for the course before we get into coding. I'll see you there in this course. These are going to be paramount to what we're working with. So for this course, there are three things. There is the GitHub repo. So if we click this link, I've got it pinned on my browser, so you might want to do the same while you're going through the course. But this is Mr. D. Burks and my GitHub/PyTorch Deep Learning. It is still a work in progress at the time of recording this video, but by the time you go through it, it won't look too much different, but there'll just be more materials. You'll have materials outline, section, what does it cover? As you can see, some more are coming soon at the time of recording this, so these will probably be done by the time you watch this. Exercise and extracurriculum, there'll be links here. Basically, everything you need for the course will be in the GitHub repo. And then if we come back, also on the GitHub repo, the same repo, so Mr. D. Burks/PyTorch Deep Learning. If you click on discussions, this is going to be the Q&A. This is just the same link here. The Q&A for the course. So if you have a question here, you can click new discussion. You can go Q&A and then type in video and then the title, PyTorch fundamentals, and then go in here. Or you could type in your error as well. What is NDIM for a tensor? And then in here, you can type in some stuff here. Hello, I'm having trouble on video XYZ. Put in the name of the video so that way I can, or someone else can help you out. And then code. You can go 3 backticks, write Python, and then you could go import torch.randan, which is going to create a tensor. We're going to see this in a second. Yeah. And then if you post that question, the formatting of the code is very helpful that we can understand what's going on and what's going on here. So this is basically the outline of how I would ask a question. Video, this is going on. What is such and such for whatever's going on? Hello, this is what I'm having trouble with. Here's the code and here's what's happening. You could even include the error message and then you can just click start discussion and then someone, either myself or someone else from the course, will be able to help out there. And the beautiful thing about this is that it's all in one place. You can start to search it. There's nothing here yet because the course isn't out yet, but as you go through it, there'll probably be more and more stuff here. Then if you have any issues with the code that you think needs fixed, you can also open a new issue there. I'll let you read more into what's going on. I've just got some issues here already about the fact that I need to record videos for the course. I need to create some stuff, but if you think there's something that could be improved, make an issue. If you have a question about the course, ask a discussion. And then if we come back to the keynote, we have one more resource. So that was the course materials, all live in the GitHub. The course Q&A is on the course GitHubs. This is quite beautiful. It is some code to automatically turn all of the materials from the GitHub. So if we come into here, code, if we click on notebook 00, this is going to, sometimes if you've ever worked with Jupyter notebooks on GitHub, they can take a while to load. So all of the materials here automatically get converted into this book. So the beautiful thing about the book is that it's got different headings here. It's all readable, it's all online, it's going to have all the images there, and you can also search some stuff here. PyTorch training steps. Creating a training loop in PyTorch. Beautiful. We're going to see this later on. So they're the 3 big materials that you need to be aware of, the 3 big resources for this specific course. Materials will be there. And then specifically for PyTorch, all things PyTorch. The PyTorch website and the PyTorch forums. So if you have a question that's not course related, but more PyTorch related, I'd highly recommend you go to the PyTorch forums, which is available at discuss.pytorch.org. We've got a link there. And then the PyTorch website, pytorch.org. This is going to be your home ground for everything PyTorch, of course. We have the documentation here. And as I said, this course is not a replacement for getting familiar with the PyTorch documentation. The course actually is built off all of the PyTorch documentation. It's just organized in a slightly different way. So there's plenty of amazing resources here on everything to do with PyTorch. This is your home ground. And you're going to see me referring to this a lot throughout the course. So just keep these in mind. Course materials on GitHub, course discussions, learnpytorch.io. This is all for the course. And all things PyTorch specific, so not necessarily this course, but just PyTorch in general, the PyTorch website and the PyTorch forums. With that all being said, we've come so far. We've covered a lot already, but guess what time it is? Let's write some code. I'll see you in the next into coding. So I'm going to go over Colab. So the way I would suggest following along with this course is the tools we're going to be using for the entire course, and that is Google Colab. So the way I would suggest following along with this course is, remember, one of the major ones is to code along. So we're going to go to colab.research.google. I've got a typo here. Classic. You're going to see me do lots of typos throughout this course. colab.research.google.com. This is going to load up Google Colab. Now, you can follow along with what I'm going to do, but if you'd like to find out how to use Google Colab from a top-down perspective, you can go through some of these. I'd probably recommend going through overview of collaboratory features. But essentially, what Google Colab is going to enable us to do is create a new notebook. And this is how we're going to practice writing PyTorch code. So if you refer to the reference document of learnpytorch.io, these are actually Colab notebooks just in book format, so online book format. So these are the basis materials for what the course is going to be. There's going to be more here, but every new module, we're going to start a new notebook, and I'm going to just zoom in here. So this one, the first module is going to be 00 because Python code starts at 00, and we're going to call this here is notebooks just into the now, through some of these. I'd probably recommend going to notebook, and this is how we're going to practice writing PyTorch code. So if you refer to the reference document of learnpytorch.io, these are actually Colab notebooks just in book format, so online book format. So these are the basis materials, and I'm going to just zoom in here. So this one, the first module is going to be 00 because Python code starts at 00, and we're going to call this PyTorch Fundamentals. I'm going to call mine video, just so we know that this is the notebook that I wrote through the video. And what this is going to do is if we click connect, it's going to give us a space to write Python code. So here we can go print, hello, I'm excited to learn PyTorch. And then if we hit shift and enter, it comes out like that. But another beautiful benefit of Google Colab, P.S. I'm using the Pro version, which costs about $10 a month, comes out like that. Hello, I'm excited to learn PyTorch. And then if we hit shift and enter, it comes out like that. Hello, I'm excited to learn PyTorch. And then if we hit shift and enter, it comes out like that. But another beautiful benefit of Google Colab, P.S. I'm using the Pro version, which costs about $10 a month or so. That price may be different depending on where you're from. The reason I'm doing that is because I use Colab all the time. However, you do not have to use the paid version for this course. Google Colab comes with a free version, which you'll be able to use to complete this course. If you see it worthwhile, I find the Pro version is worthwhile. Another benefit of Google Colab is if we go here, we can go to runtime. Let me just show you that again. Runtime, change runtime type, hardware accelerator, and we can choose to run our code on an accelerator here. Now we've got GPU and TPU. We're going to be focused on using GPU. If you'd like to look into TPU, I'll leave that to you. But we can click GPU, click save, and now our code, if we write it in such a way, will run on the GPU. Now we're going to see this later on. Code that runs on the GPU is a lot faster in terms of compute time, especially for deep learning. So if we write here, NVIDIA SMI, we now have access to a GPU. In my case, I have a Tesla P100. It's quite a good GPU. You tend to get the better GPUs if you pay for Google Colab. If you don't pay for it, you get the free version, you get a free GPU. It just won't be as fast as the GPUs you typically get with the paid version. So just keep that in mind. Whole bunch of stuff that we can do here. I'm not going to go through it all because there's too much, but we've covered basically what we need to cover. So if we just come up here, I'm going to write a text cell. So oo.pytorch fundamentals. And I'm going to link in here, resource notebook. Now you can come to learnpytorch.io and all the notebooks are going to be in sync. So 00, we can put this in here. Resource notebook is there. That's what this notebook is going to be based off, this one here. And then if you have a question about what's going on in this notebook, you can come to the course GitHub, and then we go back. This is where you can see what's going on. This is PyTorch Deep Learning projects, as you can see what's happening. At the moment, I've got PyTorch course creation because I'm in the middle of creating it. But if you have a question, you can come to mrdberg/PyTorch Deep Learning/discussions, which is this tab here, and then ask a question by clicking new discussion. So any discussions related to this notebook, you can ask it there. And I'm going to turn this, right now this is a code cell. Colab is basically comprised of code and text cells. I'm going to turn this into a text cell by pressing Command MM, Shift and Enter. Now we have a text cell, and then if we wanted another code cell, we could go like that, text, code, yada, yada, yada. Discussions comprised of code and text cells. I'm going to turn this, right now this is a code cell. Colab is basically comprised of code and text cells. I'm going to turn this into a text cell by pressing Command MM, Shift and Enter. Now we have a text cell, and then if we wanted another code cell, we could go like that, text, code, Command MM, Shift and Enter. Now we have a text cell, and then if we wanted another code cell, we could go like that, text, code, yada, yada, yada. but I'm going to delete this. And to finish off this video, we're going to import PyTorch. So we're going to import torch, and then we're going to print torch ... version. So that's another beautiful thing about Google Colab, is that it comes with PyTorch pre-installed and a lot of other common Python data science packages, such as we could also go import pandas as PD, import numpy as np, import matplotlib.pyplot as plt. Google Colab is by far the easiest way to get started with this course. You can run things locally. If you'd like to do that, I'd refer you to PyTorch Deep Learning. There's going to be setup.md. Getting set up to code PyTorch, we've just gone through number one, setting up with Google Colab. There is also another option for getting started locally. Right now, this document's a work in progress, but it'll be finished by the time you watch this video. This is not a replacement, though, for the PyTorch documentation for getting set up locally. So if you'd like to run locally on your machine rather than on Google Colab, please refer to this documentation or setup.md here. But if you'd like to get started as soon as possible, I'd highly recommend you using Google Colab. In fact, the entire course is going to be able to be run through Google Colab. So let's finish off this video, make sure we've got PyTorch ready to go. And of course, some fundamental data science packages here. Wonderful. This means that we have PyTorch 1.10.0. So if your version number is far greater than this, maybe you're watching this video a couple of years in the future and PyTorch is up to 2.11, maybe some of the code in this notebook won't work. But 1.10.0 should be more than enough for what we're going to do. And plus Q111, CU111, stands for CUDA version 11.1, I believe. And what that would mean is if we came in here and we wanted to install it on Linux, which is what Colab runs on, there's Mac and Windows as well. We've got CUDA. Yeah. So right now, as of recording this video, the latest PyTorch build is 1.10.2. So you'll need at least PyTorch 1.10 to complete this course, and CUDA 11.3. So that's CUDA Toolkit. If you remember, CUDA Toolkit is NVIDIA's programming, there we go, NVIDIA developer. CUDA is what enables us to run our PyTorch code on NVIDIA GPUs, which we have access to in Google Colab. Beautiful. So we're set up, ready to write code. Let's get started in the next video writing some PyTorch code. This is so exciting. I'll see you there. So we've got set up. We've got access to PyTorch. We've got a Google Colab instance running here. We've got a GPU because we've gone up to runtime, change runtime type, hardware accelerator. You won't necessarily need a GPU for this entire notebook, but I just wanted to show you how to get access to a GPU because we're going to be using them later on. So let's get rid of this. And one last thing, how I'd recommend going through this course is in a split window fashion. So for example, you might have the video where I'm talking right now and writing code on the left side, and then you might have another window over the other side with your own Colab window, and you can go new notebook, call it whatever you want, my notebook. You could call it very similar to what we're writing here. And then if I write code over on this side, on this video,